Hi, with our work at the Robotics and Perception Group, we're showing you how to accurately fly an autonomous agile quadrotor. And with agile, we mean really agile. But the problem with such high-speed trajectories as this horizontal circle is that quadrotors typically suffer from large trajectory tracking errors. This figure shows the x and y position of a horizontal reference circle in dashed black, which is tracked at 4 meters per second in blue. And the main reason for these large tracking errors is rotor drag, which is an effect that originates from blade flapping and induced drag of the rotor blades. Rotor drag can be measured by an IMU. So this figure shows the measured x acceleration during flight in blue with respect to the velocity in the body x direction. What we can see is that, as the theory suggests, rotor drag can be approximated well by a linear function shown in red, and that it quickly becomes significant with increasing velocity. So into the dynamical model of our quadrotor with control inputs in green, we incorporated rotor drag by the terms in red, and in our paper we proved that this model is differentially flat. We then used the differential flatness property to compute feed-forward terms from a reference trajectory in our proposed controller, which compensate for the rotor drag. So let's fly the circle again with increasing speed. In the animation on the top right, you can see the reference trajectory in black, tracking without considering rotor drag in blue, and tracking when considering rotor drag with different parameters in red and yellow. With increasing speed, the blue point gets farther and farther away from the reference, while the red and yellow points always stay close. Since we are considering a more accurate model in the controller, this also applies to any other trajectory, such as this figure 8. Thanks to our method, by considering rotor drag in the controller, we could reduce the trajectory tracking error of quadrotors by 50%. And the best thing is, it is all open source. So please check it out on GitHub and try it out yourself. Thanks.